Okay, last but not least, one more possible capture mark release. So similar to the last one, but we're going to use a little bit more data. It's actually kind of similar to a combination of the first and second methods that we had here. So we're going to use 4 weeks worth of data again. We are going to go out and take a sample every week, and we're going to keep track of the number of squirrels that are marked in the population and the number of new squirrels that we're marking, or the number of unmarked squirrels that we capture, whichever way you want to think about it. So every time we capture, we're going to mark anybody that didn't already have a mark. Okay, so we're going to start like last time, and we're going to plot these pairs. So previously marked, when there were 0 marked, we captured and marked 120. So we have that same piece of starting information. After that, we had 120 marked squirrels. We went out and we captured, and I don't even actually have the information here about how many were captured because we don't need it for this one. 51 of them were not marked. So we captured 51 squirrels that we hadn't before, and we added a mark to them. After 3 weeks, we now marked 171 squirrels total, so that's roughly in the middle here. And once we brought our sample in, there was 38 squirrels that were not marked that we added a mark to. So that's about here. And I'm actually going to label these. If your points fall right on a grid line, great. Otherwise, if it's reasonable, if you don't have a massive data set, label them for me real quick. So this was 171, 38. And this one was 120, 51. Okay, and then last but not least, week 4, we'd marked 209 squirrels total. We went and we captured squirrels, and of those squirrels, there was 21 of them that didn't have marks already. So this was 209, marked 21 new ones. Okay, so first thing that I'm hoping we notice here is that it doesn't look like these points lie exactly on a line. And you can see if you're reading my questions below for part B, how can you tell that, or how can you verify that, I guess is kind of what I'm asking. And one way to do that is just to calculate slope. If you count the slope between these points, so we went over 120 and we went down, 69? And then we went over 51 and we went down 38, 48, 13. If you calculate those two slopes and they are not the same, then there is no way that those points are on the same line. That said, if you calculate slopes between two completely distinct pairs of points and they're the same, that doesn't guarantee that those 4 points all lie on the same line. But if 1 point is in each of those calculations, I'm going to quit talking. It's going to be confusing without an example. Anyways, these do not fall on one line. And if you're ever in doubt, you can always just pick some pairs of points and calculate slopes. And if the slopes are different, then they're not going to lie on a single line. So in this situation, this is kind of the looking ahead to the new stuff we're actually going to do instead of just the review. What we would do is either just by eyeballing it or using technology, we would find a line that does the best we think it can possibly do of approximating the trend that we're seeing. So let me go back to my line. Let's see, maybe I think that my line looks something like, oh, I don't know what, maybe like that. Sort of split the difference between that lower point and those upper points. You can probably wiggle this around a little if you wanted to. I don't know that I do, but maybe I'll do that just a little just to be interesting. Okay, so I'm not claiming that is the best, but just to give you an idea of how we do it, we'd look and we'd say this kind of follows the trend of the points. It kind of falls between the upper points and that one that looks a little low at 120.51. So there's a possible line. Not necessarily perfect, but it is a possible line that seems to do a decent job of fitting the trend. Without even finding if I could speak, finding the equation, we could start to talk about points on this line. I'm going to go ahead and switch colors so that I don't confuse the data points. Let's see, let's go back to blue again. Okay, so looking at the actual line, it looks to me like this goes through 0, 135, and maybe out here it goes through, I don't know, just a little before it would hit another one. So what are these, 20? So maybe this next one would be at 240, so maybe 238. So I am still just kind of estimating here, but it gives me an idea. So there's my X and Y intercepts. The context is a little different here than in problem 1, so let's think carefully about what this means. So the vertical intercept, 0, 135, that says that according to our linear model, which again isn't perfect, it's approximate. According to the model, if we went out without having marked any squirrels and put in however much effort this biologist put in, we should be able to catch the 135. So our data actually says 120. Oh, I'm sorry, this is a 125, not a 135. Our data says 120, our model says 125. That's how models work. They're not perfect. The X-intercept, that one's interesting to us because we didn't have data that went that far out. That says if you've marked 238 of the squirrels, then when you go out and capture, you shouldn't have any unmarked. So I actually think it is giving us sort of the same information as the first one in a different way. I still think what that's getting at is that if you mark 238, you're not going to be able to mark any because you've got all of them. So the population is roughly 238 squirrels. Okay, so those are my intercepts. The equation for the line. Okay, so I'm going to pretend temporarily that I don't have this y-intercept because I do want to remind you of some other tools for finding equations for lines. A good one is point slope form. You don't ever have to use point slope form. You can always use slope intercept, but there's a chunk of the time in Calc 1 where we're doing a lot of finding equations for lines, and this is a really kind of nice, quick way to do that. To find that, you need a slope and you'd need 1 point, an x1, a y1. So here, this is still slope just like before, and x1, y1 is any point that's on your line. So if I'm looking at my line, I can try and count out slope. It actually still looks like I made it have a pretty nice slope. But if it's not nicely hitting all your grid lines, you can also just try and snag a couple of points. So I'm going to estimate that my line goes through 60, what do you think that is? Maybe like 94. And then let's pick one more. This actually looks like it hits pretty much right on a grid line. So let's say it goes through 180, 30. And you can always just do your change in y over change in x to find the slope. So if I make this my, I don't know, say this is my point number 2 and this is my point number 1, it doesn't matter. You just need to stick with it. We could say y2 is 94, y1 is 30, x2 is 60, and x1 is 180. So I don't care which point is point 1, point 2, but as soon as you put the 94 first on the top, that means the 60 that's paired with it has to go first on the bottom. That's the key thing in calculating slope. So what did I get here? I got that I went down, or I'm sorry, I didn't go down, I went the way I wrote it. So if your change in y is positive 64, your change in x would be negative 120. And I can even reduce that one a little bit. So if I cut it in half, I'm going to get 32 over negative 32 over 60. I could keep going. Let's just divide, what can I get? A 4 out of that for sure. So 8 times 4 is 32, and 15 times 4 is 60. Okay, so there's a reduced slope. In a context like this, in a word problem, you can convert it to a decimal. That would be fine with me. I'm going to go ahead and leave it for now just because I don't feel like doing the calculator work. So I can fill in the slope part of this. And then all I need is a point, and I just picked out 2 points. So take your pick. I'm going to choose my point 1 just because that 180 and that 30 just looks like it might be nice to do the arithmetic with. So my y value of my point is 30. My x value is 180. Okay, so I have a y minus 30 equals negative 8/15 x Ooh, do I want to do that in my head? I could, because I think 15 is going to divide in nicely, but to save you from having to watch me make arithmetic mistakes, I'm going to double check myself. So 8/15 times 180 is 96, and since they're both negative, that's going to become a plus 96. And then my very last step, let me get rid of this line in my way, would be to add 30 to both sides. So negative 8/15 x plus 126. So there is a model that roughly fits the trend of my data. So you'll notice it's not like crazy far off from the model we got the first time around with similar data. But since it's not a perfect straight line, we will have a little bit of wiggle room there for what that looks like, since the data is not a perfect straight line. Okay, last thing I'm going to do with this one is another slope explanation. So remember again, we have negative 8/15 should be our change in y over change in x. And our y represents the number of new marks, and our x represents the number previously marked. So if you keep your slope as a fraction, as opposed to turning it into a decimal, which would not be wrong to do either, I would say what I've got right now says that for every 15 squirrels that you previously marked, the number that you catch without marks or tags is going to drop by 8. So if there are an additional 15 previously marked squirrels, you're going to catch 8 fewer unmarked squirrels. Okay, so those can get a little tricky, the slope interpretations, but just try and practice. Be careful with them. You should have some good practice when we get to linear functions as well. Okay, thanks for watching.